All right, it is recording now.
All
So,
right, good. Okay.
yes. So, welcome. Thank you for joining us. For people watching this, it is my extreme honor and pleasure to be talking to Dr. Temple Grandin, a distinguished professor of animal science at Colorado State University and the author of multiple New York Times bestsellers, titles like Animals in Translation, Animals Make Us Human, and The Autistic Brain, as well as Thinking in Pictures and Emergence. Uh, Dr. Grandin has also written a book for kids. That would be Different Kinds of Minds, out November 2023. And we are going to be talking about that today. Dr. Grandin, with your permission, I would like to record our conversation. Is that okay with you?
Yep, I'm Temple Grandin, and you have permission to record this conversation and put it up on YouTube or any other platform. So I
Marvelous.
have to say that to be legal. So
Yeah, no, it's a good thing to
okay.
have on record.
Yeah.
Well, thank you so much. And I think I just want to jump right into the very book in question. I'd love it
Okay.
if you could tell me a little bit about where did Different Kinds of Minds come from and why did you choose to write a book for young people?
Well, originally I had my the adult version of the book, Visual Thinking, Hidden Gifts of People Who Think in Patterns, Pictures, and Abstractions. Um, One of the things that made me write this book, and that was the big COVID project originally, is I'm very concerned about losing skills. And just before COVID hit, I went to a state-of-the-art pork processing plant. In fact, I went to two of them and discovered all the equipment came from Holland. Then I went to a poultry plant. The equipment all came from Holland in 100 shipping containers. Then I went to the Steve Jobs Theater, and the structural glass walls came from Italy and Germany. And then I read in The Economist that the state-of-the-art electronic chip-making machine was made in Holland, even though the mathematics behind it was invented here. We've got a skill loss issue. And I've always been interested in different kinds of thinking. And I am an object visualizer. Everything I think about is a picture, like a photo. Mm-hmm. Absolutely cannot do algebra. And object visualizers are good at art, mechanical things, photography, and animals. And I worked with a lot of really skilled shop people that invented equipment. They didn't just manufacture equipment, they invented equipment. And they have a lot of patents. And a good number of these people were either autistic, dyslexic, or ADHD. They were the kids that were different that took shop and were paying the price for taking out the hands-on classes. Holland has not taken out the hands-on classes. This is one of the reasons for writing this book. Then I discovered research that showed that there's a difference between an object visualizer like me and a mathematical visual spatial thinker who thinks in patterns. Think pictures versus patterns. Mathematicians are patterns. Music and math. That's your traditional engineer with a degree. But the clever mechanical devices come out of the guys in the shop, and they're not just manufacturing the things. They are inventing things. I've looked up their patents. I get annoyed when the degreed engineer says, well, those people just manufacture stuff. I've worked with them for 25 years. They were inventing stuff. And people forget, back in the days when the patent office started, all the inventions were mechanical devices in the very beginning. An airplane made by bicycle mechanics, for example.
Mm-hmm. That's awesome.
And then, of course, you have your verbal thinkers
mm-hmm.
who think in words. And a lot of people are mixtures of the different kinds of thinking, but one kind of thinking will predominate. So the first step is realizing that different kinds of thinking exist. And I'm especially concerned about the object visualizers because when I did a book signing for the grown-up edition of this book, Visual Thinking, I was shocked to do one of the talks at a school, and I talked to the principal, and he didn't know that object visualization existed. And he was a high school principal. And I think part of the thing, they think you need algebra to think logically. No, let's, for certain kids, replace algebra maybe with a geometry, accounting, statistics, or business math. I'm not suggesting totally getting out of math. but get a math that's less abstract,
Mm-hmm.
because we're screening out some of these minds that we really need. And I'm very concerned about this. And then and I think we got to start getting kids interested in different things young. I'm concerned today that a lot of kids aren't getting exposed to enough stuff. How can you know what you're good at unless you're exposed to stuff? We got kids growing up that never used tools. Kids growing up today that haven't played musical instruments, never made a paper airplane. We need to be exposing elementary school kids, middle school kids to lots of different stuff so they can kind of see what they're good at, what they're bad at. Mm-hmm. It's, I gave a talk at a construction management conference very recently, and they were asking me, how do we get kids interested? I said, the community college is too late. Kids need to be working with tools in elementary school, even if it's just making things out of cardboard. They've got to get exposed that building things is fun.
All right.
And the thing is, we need these skills. I do a lot of talks to businesses. And I said, the first step is you have to realize that different kinds of thinking exist. And they bring different skills into a project. Mm-hmm. And we need all these different kinds of skills. We've got infrastructure falling apart, electrical systems falling apart, water systems. And my kind of mind's the ones that's going to keep those things going. You need us. Been on a lot of questionable elevators recently, not getting fixed. I went to a big fancy hotel just real recently. Mm-hmm. They had a 6-month extension inspection sticker stuck on the certificate in the elevator. That was a month ago.
Ooh.
Yeah, that's not good. Mm-mm.
All right. Well, thank you. And of course, a lot of the book also goes into how each person's particular brain adapts. So how did the skills of your own particular brain adapt elements of your adult books to a book for kids? So what was the process you used to sort of make this kind of adaptation?
Well, you have to summarize it, for one thing. Mm-hmm. But the one thing I was very adamant about is the science behind the different kinds of thinking. I wanted to have that explained. And I had pressure to cut the reference list way down. I fought that. Now, I did cut the reference list way down, but I made sure that the really important studies that support the idea of different kinds of thinking are in there. I made sure the science was in there. Mm-hmm. So basically, and we left the things in there that, I think kids would be the most interested in. Also, we have pictures in this book. Mm-hmm. I got asked, why didn't I put pictures in this? The publishers wouldn't let me.
Oh,
we got some cool pictures in this version right here. Yeah, which the other version doesn't have. Pictures of famous inventors in there, but also drawings. Got a picture of me standing in the middle of the Steve Jobs Theater screaming, "We don't make it anymore."
That's a good picture.
Yeah, it's a really cool picture.
Yeah, that's a really good one. I like the hug machine picture too.
Yes, and I actually built that. And that's, skilled trades stuff, and that's pneumatic controls. Mm-hmm. And the way I figured out how to build that, I worked in a dairy, and I looked at how the pneumatics worked on the gates. Mm-hmm. It's but we need the skills of the different kinds of minds. Mm-hmm. Because, you see, the verbal thinker tends to overgeneralize, have a big concept, a great big concept. Where my kind of mind thinks in specific things you might need to do to achieve some of the things in that concept. All right, let's take the concept of an inclusive classroom. Mm-hmm. Well, okay, how do you do it? The first thing you need to do is you've got to get bullying under control. Absolutely, you've got to get that under control. I was bullied in high school. It was horrible. Mm-hmm. Now, there's some individuals that think differently. They have problems with flicker on LED lighting. Some people get migraines and stuff. I don't see flicker on LED lighting, but some people do. So you're building a new school. Let's get some LEDs that don't flicker, and you can test them. You can take your phone out right here and film it in slow motion video with this. And the ones that flicker, you will find them. I learned that from a lighting contractor. The other thing is a lot of the minds that are different have trouble with remembering long strings of verbal communication, like sequence. Well, give me a pilot's checklist for the sequence of how to do the chemistry experiment or how to do some other thing. That's a simple thing to do. Another thing that was done with me when I was a young kid was my teacher in elementary school explained to the other children I had a disability, but it wasn't visible like a wheelchair, and that the other kids should be helping me. So I managed to avoid bullying in elementary school. That's because my teacher explained to the other kids they need to be helping me. So that's 4 things that help make me be successful in a regular school, in a small classroom in a regular school by the time I was 5. But you see, these are specific things that the school can do. And then there's some kids with autism will need some sensory breaks. But again, I'm talking about specific things. And while we're on sensory, let's say the child hates the school bell or hates the vacuum cleaner. Let the child turn it on and off. And now I'm saying, Mr. Russell's vacuum cleaner. Now I was in kindergarten. It had a bag this big. I was afraid it's going to suck me up. But when you're 5 years old, it looked much bigger than it really was. And I was terrified of Mr. Russell's vacuum cleaner and the sound of it. Well, what they should have done is let me turn it on and off and let me play with Mr. Russell's vacuum cleaner, where I controlled it. And a child that might be afraid of that loud sound might actually get to like it when they control it. This is really important. One school, kid was terrified of the school bell. They took him down to the principal's office and they let him ring it 25 times when school was closed. That actually worked. You see, but that's something simple that you can do. It's also something specific. It's not a great big broad concept.
That's great. So at one point in the book, you refer to filers and pilers.
Oh yeah, and I got a picture of it too.
Oh good. Oh good. Yeah.
Now I have a big messy pile of books here, but I made sure it's out of camera range. But I'm the one. If you look around my desk, I got piles of junk all over the place, but I know where I've piled the different things. I'm not. Yeah, I know. I tend to have big files that are piles, and this pile is journal articles I'm reviewing, for example. This pile is animal welfare guidelines, and there might be big piles.
Yeah.
This pile over here is all the tax record junk.
This makes sense to me. I'm a piler myself,
okay,
which is why I'm not anywhere near my desk right now, because it makes sense to me. And if for folks who haven't read your book yet, a filer keeps everything in its place.
Very, very neat. You see, a verbal thinker is very linear in their thinking. The other thing is the verbal thinker leaves out detail. That's why they talk about a broad concept like an inclusive classroom. Well, and there's been a lot of broad concepts in education that were rubbish. I remember back in the 60s, the teaching machine era using B.F. Skinner methods. Oh, that was bad. Yeah, it was a big, broad concept that absolutely did not work. That was in the 60s. I remember all that stuff. But so very linear, leaves out the detail. I tend to get too much detail. So then you have to figure out, well, which details are important. What's the really important stuff?
Yeah.
Some things are more important than other things. I can categorize them.
Well, in terms of since you're a piler, how could you explain to a filer that your system makes sense and works? Because they look at it,
I just explain to them what's in each pile.
Oh, okay.
And there's a lot of stuff in each pile, but I could go through it relatively quickly. It might take me 5 minutes to go through the pile and find the stuff. And then if somebody moves it, I'm in trouble. Then I can't find it. If somebody moves it. But then there's a point where I just get too much junk and I got to get rid of some of the stuff.
Yeah. No, true.
There's a point where you need to do that.
Yeah. That's what I call my annual cleanup.
Yeah. Then I just go, I just got to get rid of a bunch of stuff. And there's a bunch of stuff that's going to go out in the dumpster. I've just got to get rid of it. I got too much stuff.
Yep. So at one point, there's a meme actually going around the internet where they show an apple and they show it from a very clear non-existent, and how people can visualize an apple. And you talk about visualization in your book. And
Yeah, all
people
right. Visualize an apple. I'll tell what I think of. I'm seeing an apple it's in my refrigerator. I'm seeing the apple cut up for breakfast and mixed with some other fruit and granola and yogurt that I had for breakfast. But now I'm seeing the apple on the back of the Apple laptop. You see, now I jumped to the apple on the Apple laptop. Then one of my students decided to put a picture of Snow White biting an apple on her Apple laptop. So now I'm seeing that. Now I'm getting into the category of cartoons I loved as a child, like Peter Pan and Snow White. Okay, that's how I got from Apple to Peter Pan and Snow White. There is a logic to it, but it's associative thinking rather than linear thinking. Now, in a lot of design work and invention work, that associative thinking can be really, really helpful. One of the examples I have in different kinds of minds is the discovery of a big chemistry discovery that was based on a picture. You see, that was associative thinking. You see, it's not linear, but it's also not random either.
Right.
Okay, I just walked you through. So what Apple thing is going around on the internet?
Right. Well, the thing going on the internet is just some people can't possibly imagine that another person could perfectly imagine an apple. They hear the word apple and they see the word.
That's a total verbal thinker.
Right.
And that you also have some people that have aphantasia, and that got kind of, I think, left out of this book. Aphantasia is someone has no visual thinking at all. They might be mathematical, but the thing that's weird is they can't consciously have visual thinking, but they can sometimes have visual thinking in their dreams. Now, when I was young, I thought everybody thought in pictures like me. I didn't know until my late 30s that other people think in words. I didn't know that. I thought everybody thought the way I did. And when I get discussions at conferences, I've had people come up to me and go, "Oh, I didn't even know that people can think differently." But the visual thinking is a different way of problem solving. You see solutions to problems. That's what you do.
So why is it important to have that information in your book for kids?
Well, because it's going to help kids, end up in careers where they might find out what they're good at. Visual thinkers need to be exposed to all kinds of making things, art. And I know visual thinkers who are great photographers, and they did not do well in school. Also really great at working with training animals, horses and dogs. Very, very good at that. Because an animal does not live in a word-based world. It lives in a sensory-based world. And then the mathematical kids take off on math. So let's say you have a kid that's mathematical, you need to move them ahead in math. Don't make them do boring baby math. Move them ahead in math, or her ahead in math. I have Katherine Johnson there as an example, the famous mathematician who calculated the orbits and the suborbital flights for the Mercury and the Apollo projects. And her math education was handled right. She was moved ahead in math. Now, she had all kinds of discrimination. She was black. She wasn't allowed to use certain bathrooms and things like that. That was really bad. But her math education was handled right. She was moved ahead. And if that hadn't been done, she probably couldn't have done those calculations. You see, that's an example of developing her abilities. Abilities do need to be developed. They can't develop. How could she learn advanced math if she was never exposed to it? She wouldn't.
That's true. Well, now you also have
a lot of people again are mixtures. I want to emphasize a lot of people are mixtures, but you get somebody that's got a label, you tend to have an extreme mathematician or maybe an extreme object visualizer like me.
Yeah, and I'm a mix. I have both the visual and the words, but that just means I daydream a lot of movies that I just make up in my head. You do have another part in the book where you talk about object thinkers and spatial thinkers, and how they can work together to create.
That's right.
Yeah.
And the object thinkers, let's go back to food processing plant, makes all the mechanical equipment. They're the people that work in the shop. Often just grew up taking shop classes. They're inventing and patenting mechanical devices. Then you're engineering with a degree, boilers, refrigeration, make sure the roof doesn't fall down. Do the things that require mathematics. And where we're losing skills is with the object visualizers that make mechanical things. Because these kids are getting shunted into special ed. They can't do algebra. There are some states where I wouldn't be able to graduate from high school. This is something I'm very concerned about. I had to drop a physics class. I had to drop a biomedical engineering class. But biomedical needs people like me. Because before I had to drop that class, I did a term paper on artificial hips. This was back in the 70s. And there was a huge mistake made in artificial hips with a metal on metal hip joint.
Yeah,
And this
I remember
gunk
that.
that went out into people's bodies. I wouldn't have made that mistake. I would have seen it. It would have been stopped very, very promptly. That's where you need someone like me who can't do the math, say, well, this hip, we just shouldn't be using it because this metal gunk that's going into people's bodies. See, I would have seen it. Go, oh, no, this is not going to work. That was a major mistake that could have been stopped by somebody like me who can't do the higher math. But then you have to have the math to make sure the joint's strong enough and it's not going to break. You see, you need to have both.
Right. And that's how you get the Eiffel Tower. And that's how you get, like,
but you have to be aware that different kinds of thinking exist. And I've had some degree, I had a degree engineer one time, just dismissed the people that work in the shop as just mere manufacturers. No, I worked with people in the shop that were inventing and patenting equipment. And two of these people were undiagnosed autistic. I can't give you their names, but when I type their names in and then put patent beside it, a whole bunch of patents come up, and the stuff that they've patented, the industry is still using it now.
So are there cases where object thinkers and spatial thinkers, maybe where that partnership doesn't work out in some way, maybe because too much pressure is placed on
the first thing is you have to realize there needs to be a collaboration. Like when we did the adult version of the book, I did the rather disorganized rough drafts, and Betsy, my super verbal co-author, she straightened everything out. And we worked together fully knowing how our thinking was different, fully aware of our differences.
But in cases where
she rearranged us, it's just like magic to me. But then if some of the ideas that I thought up, the original ideas, she wouldn't have thought up. You see, you need both.
Yeah, that's true.
I'm noticing, I review journal articles, and one of the bad things I'm noticing now is the papers are getting more and more mathematical, but then they leave out really important parts of the methods section of an experiment. What breed of pig did you use? What did you feed your chickens? Really basic things that can totally change the results. What did you mix your cancer cells with in a cancer study? Which type of mixer did you use? It can totally change the results. So when I review journal articles, I'm like ripping into the methods section, because they may have all this fancy math, but then they've left out things in the methods that if somebody tries to replicate that experiment, it's not going to work. Methods are important. It matters how you housed your animals, what you fed them, and how you observed your behavior data. Okay, we got training artificial intelligence to monitor dairy cows. Well, they just said they observed the behavior of the dairy cows to train the AI system. Well, how did you do it? How did you do your observations? You didn't tell me how you did it. Yeah, it's really important. Methods are important. But you see, when I read a method section, I want to visualize how they did this experiment.
Yeah.
How'd you choose your sample population for a drug trial, for example? It matters. You see, and you've got to write that up.
So going back to your book, was there anything you wanted to include in it that you weren't able to?
We pretty much got the things I really wanted to include in it. It's a really good summary of the other book. And I made sure that, because I knew there's going to be a lot of people that are going to read that, they might not even know about the other book. even though it's on the cover, but I might not notice that. I wanted to make sure the most important things in there were very clear about the 2 kinds of visual thinking. Object visualization, like me, who's bad at abstract math, visual spatial pattern thinking, who's good at math, and then word thinking. So these 3 kinds of thinking are well described. And I added, they did not take out a bunch of the references on that. I took out a pile of other references, but not the references on the different kinds of thinking, because that's one of the most important things. And I have business people that say to me, what's the most important thing they can learn? I said, the different kinds of thinking exist.
Yeah.
And they bring different skills in for problem solving. We have a shortage of mechanics right now. I did a talk for an airline, and they were saying, well, how do we find the good mechanics? Well, maybe you want to look at pictures of the car that he rebuilt, because that would be your best mechanic. They can see how the engine works. They see it. And you look at a jet engine with the covers off of it. There's all kinds of intricate mechanical things in there. Yeah, and you can look that up online.
Sure, yeah. Would you be interested in doing more books for kids?
Well, I actually have some other books for kids.
Hey.
I've got Calling All Minds. That's my kids' project book, where kids don't tinker anymore. In this book, I talk about parachutes I made as a child, little bird kites that I spent hours tinkering with. We have kids today that have never made a paper airplane. They've never made a paper snowflake. They haven't used scissors. Get kids doing things. I have another book called The Outdoor Scientist, where it's getting kids out looking at stars, observing animal behavior, observing plants. So I have 2 kids' books, mainly be really good for elementary school, and some of the projects are suitable for middle school. And they're all inexpensive things they can do. But when I did a book signing for Calling All Minds, when that came out 5 years ago, I was shocked that roughly 20 to 30% of the elementary school kids in a suburb of Denver had never made a paper airplane. They're totally removed from the world of the practical.
Yeah.
This really bothers me. Oh, and we need people that do those things. Kids don't tinker with stuff anymore.
Yeah.
And I know, and then I go on a plane, everybody shuts the window shades, glued to the electronics. Kids need to be looking out the window of an airplane.
Yeah.
That's what kids need to be doing.
Yeah.
When I first went on an airplane, I was fascinated about going above the clouds. My first airplane trip, I was 12.
That's good. Well, and I guess I could talk to you all day, but I should probably
we got a few more minutes before I have to get off. I am watching the clock. We got about 5 minutes.
Okay. Well,
if
let me
something
do
else you want to ask me, I can do that before I have to get on the next interview they've got lined up for me.
Sounds good. I'll just do one final question. What are you working on next? What are you working on right now?
What am I working on right now? I think one of the most important things I can do at the age of 76 years old is I want to get young people turned on so they can get into good careers. So I'm a big proponent and exposing kids to all different kinds of things, but also when I talk to college students, I still teach a university class. I tell students, do different internships, volunteer to work on different people's experiments. So you see lots of different things in your field. Find out what you like, find out what you hate, and get into a good career. And that I do a lot of speaking engagements now. That's mainly what I'm doing right now, because I want to help the young people get into careers that they're going to really like, and they can also do constructive, good things in the world. That's basically what I'm working on right now.
Well, that is a perfect way for us to end the conversation then. So,
well, thank you so much for having me. And I won't leave the studio right away because I know the recording has to upload.
I'll stop it right now.
It's okay to stop it?